હલો સર કયું એક મિનિટ લાઈવ જોઈ લ્યો ને ખાલી પેલા ઈ તો રોબોટ નહીં ઓલું છે ને લોગો ઉપર જાજો ફરીથી બીજું સેશન કર્યું ચાલુ દેખાય છે બધું પ્રોપરલી દેખાય બધા આવે છે ડન ને હા બસ એ તો સ્ટેબલ રાખી દઉં જો ઓલા રોબર્ટભાઈ ને બોલાવો કે હું આવું નીચે એમાં છે ને સર મોડમાં જશો ને
નહીં બેહો Hello.
મોબાઈલ ન હોય ને બરોબર.
Spark, ignite, innovate. It is my honor to welcome you to this gathering of curious minds and innovative thinkers. And as we gather here today, I am reminded of the profound words of Albert Einstein. The most beautiful thing we can experience is mysterious. It is the source of all true arts and science. Today, we embark on a journey to uncover the incredible, to explore the uncharted, and to push the boundaries of human knowledge. On behalf of the entire Christ family, I, Priyanshi Sharma, a second-year BSc student, extend a warm welcome to the 15th National Science Symposium 2024. This esteemed gathering brings together inquisitive minds in science to share their passion, curiosity, and groundbreaking research. The symposium is proudly organized by Christ College Rajkot, sponsored by Guj Coast Gandhinagar. I would also like to appreciate GBRC Gandhinagar as our advertising partner. On this momentous occasion, we are immensely privileged to welcome distinguished keynote speakers of the day, Professor L.S. Shashithara, Director, NCBS Bengaluru, Dr. Madhvi Joshi, Scientist D, Joint Director, GBRC Gandhinagar. Guest of Honor, Professor G.C. Bhimani, Head, Department of Statistics, Saurashtra University, Rajkot. Patron of Science Symposium, Reverend Dr. Father Chauman Thomana, Director, Christ Campus. Reverend Father Stanley Joseph, Finance Administrator, Christ Campus. Chair of Science Symposium, Dr. Yvonne Fernandez, Principal, Christ College. Ms. Nymphia Gogia, Principal, Christ Polytechnic Institute. Convener of the symposium, Dr. Neha Jangbari, Assistant Professor, Department of Microbiology. Co-convener of the symposium, Mr. Jagrat Tripathi, Head, Department of Mathematics. Invited judges, faculty members, and student delegates from across the nation. As we converge at this science symposium, let us celebrate India's emergence as a hub for interdisciplinary innovation, India's remarkable growth in academic research and development signifies its transition from a consumer to a creator of knowledge. With a thriving ecosystem of researchers, government support, and international collaborations, India is poised to continue making significant contributions to global innovation. Today, we gather here to accelerate this momentum, foster collaborations, and unlock the transformative potential of Indian science. It's rightly said, prayer is not asking, it is a longing of the soul. It is both an incredible expression of faith and a humble gesture of surrender towards the divine. Before we commence our activities, I would like to call upon Ms. Vidhi Chani and Ms. Harshvi Nagrecha, students from second year, to begin the symposium by seeking the blessings and presence of the Almighty.
Address health-related challenges posed.
मृत्युंजयाय रुद्राय नीलकंठाय शांभवे अमृतेशाय शर्वाय महादेवाय ते नमः मृत्युंजय महारुद्र त्राहि मां शरणागतम् जन्म मृत्यु जरा व्याधि मुच्यते कर्म बंधने जय काल महाकाल विकराल शंभो जीवन हो या मृत्यु दोनों ही तुम हो जन्मों जन्मांतर की लड़िया ये करिया हरियो ने हर जीवन रखवाल तुम हो जय काल महाकाल जय काल महाकाल जय काल महाकाल जय काल महाकाल विकराल शंभो जीवन हो या मृत्यु दोनों ही तुम हो जन्मों जन्मांतर की लड़िया ये कड़िया हरिओं में हर जीवन रखवाल तुम हो जय काल महाकाल जय काल महाकाल जय काल महाकाल जय काल महाकाल सृष्टि के संचालक महाकाल तुम हो तुम ही सुख तुम ही दुख निर्वाण तुम हो सूरज से तेजस्वी सागर से निर्मल चंद्र भी तारे भी ब्रह्मांड तुम हो जय काल महाकाल जय काल महाकाल जय काल महाकाल जीवन की नैया तुम पतवार तुम हो इस पार उस पार मझधार तुम हो कंचन ये भक्षण ये तुमसे बना है गुरुजे जो भक्ति कर ओंकार तुम हो जय काल महाकाल जय काल महाकाल जय काल महाकाल हिमालय के सरकार सिंगार तुम हो गंगा की पावन सी इकरार तुम हो डम 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 का एक नाद तुम हो शंखों के हृदयों की हुंकार तुम हो जय काल महाकाल जय काल महाकाल जय काल महाकाल कृपाल शंभो त्रिलोक व्यापे है तेरे चरण हो तेरी कृपा पर जीवन प्रकट हो तेरे ही कोकुल से सृष्टि वसम हो जय काल महाकाल जय काल महाकाल जय काल महाकाल
Thank you, Viti and Harshvi, for invoking God's blessings on all of us. Deep Jyoti Param Brahma, Deep Jyotir Janardana, Deepo Haratu Me Papam, Deep Jyotir Namostute. Lighting a lamp is a whispered promise to the universe. I will chase the darkness and find my way home. As the light rises, may our fears subside. May dreams take flight and our true selves shine bright. To their excellency, I would like to invite Professor L.S. Shashidhara, Dr. Madhvi Joshi, Professor Girish Bhimani, Reverend Dr. Father Chauman Thomanna, Reverend Father Stanley Joseph, Dr. Yvonne Fernandez, Ms. Nymphia Gogia, Dr. Neha Jangvari, and Mr. Jagrat Tripathi to come up on the stage and light the lamp and inaugurate this program.
शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपो हरतु मे पापं सन्ध्यादीपनमोऽस्तुते ओ दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः ओ दीपब्रह्मरूपस्त्वं ज्योतिषां प्रभुरव्ययः आरोग्यं देहि पुत्रांश्च मतिं स्वच्छामि मे सदा रवेरस्तं समारभ्य यावत् सूर्योदयो भवेत् रवेरस्तं समारभ्य यावत् सूर्योदयो भवेत् यस्य दृष्टिर्गृहे दीपः तस्य नास्ति दरिद्रता शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम्
The lamp has been lit, and with its gentle yet unwavering flame, it guides us symbolically towards wisdom, knowledge, and mutual growth. Thank you to all the dignitaries. A single note can create a symphony. A single brushstroke can paint a masterpiece. A single step can begin a journey. A true educator has the passion to inspire, patience to guide, and the perseverance to nurture young minds. Our beloved principal, Dr. Yvonne Fernandez, is a maestro who orchestrates learning with elegance and precision, creating a harmonious blend of knowledge and curiosity. Let's extend a warm welcome to our esteemed principal, Madam, as she addresses the gathering.
Good morning and a very warm welcome to the 15th National Science Symposium 2024, organized by Christ College and sponsored by Good Coast. It is my privilege and a pleasure to extend a heartfelt welcome to each and every one of you. Our keynote speakers, Shanti Swarup Bhatnagar Awardee, Professor L.S. Shashidhara, and Dr. Madhvi Joshi, Joint Director, GBRC Gandhinagar. Our guest of honor, Professor G.C. Bhimani, former Vice Chancellor, Saurashtra University. The symposium patrons, Campus Director, Reverend Father Dr. Joman Tamanna, and Finance Administrator, Dr. Stanley. Our distinguished guest, Ms. Nymphia Gogia, Principal, Christ Polytechnic Institute. Respected judges and faculty members from across the nation. The convener of the symposium, Dr. Neha Jungbari, and co-convener, Mr. Jagrut Tripathi. Esteemed members on the staff of Christ College, delegates to the symposium, and my very dear students. In the words of Carl Sagan, somewhere something incredible is waiting to be known. This quote beautifully captures the spirit of scientific exploration and the relentless pursuit of knowledge that brings us together for this symposium. It encourages us to keep a sense of wonder and curiosity alive, reminding us that the pursuit of knowledge is endless and always filled with the promise of new discoveries. Christ College epitomizes the pursuit of excellence and is renowned for providing quality education to the youth. Beyond fostering academic achievement, the college is deeply committed to holistic development through a variety of enriching activities. For nearly 2 decades, Christ College has been organizing national and international conferences, workshops, and symposia, creating opportunities for students and faculty to engage with and stay abreast of the latest global advancements. At this juncture, I take the opportunity to place on record my deepest gratitude to Good Coast for the financial support in organizing this National Science Symposium. We are deeply honored to have amongst us our distinguished keynote speaker for the day, Professor L.S. Shashidhara. Dr. L.S. Shashidhara, a distinguished professor in the Faculty of Biology at IISER Pune, is currently serving as a Center Director on deputation at NCBS Bangalore, one of India's premier research centers for biological sciences. Alongside his role at IISER Pune, he also contributes as a visiting faculty at the Ashoka University, Sonipat. Professor Shashidhara is a Shanti Swarup Bhatnagar Awardee recognized for his outstanding contributions to biological sciences in 2008. So we are truly privileged to have you as a keynote speaker for the 15th National Science Symposium organized by Christ College. It is with great respect and enthusiasm that we extend a warm and hearty welcome to you, sir. We are equally delighted to have as our second keynote speaker, Dr. Madhvi Joshi, Scientist D and Joint Director at GBRC Gandhinagar. Having once been a part of Christ College faculty, Dr. Joshi brings back with her a wealth of knowledge and insight. Welcome back, madam. We eagerly look forward to your address. I extend a very hearty welcome to our guest of honor, former Vice Chancellor of Saurashtra University, Professor G.C. Bimani, a versatile academician and visionary leader who has always supported Christ College since its inception. We are extremely grateful to you, sir, for the support you have rendered to our college. It's a pleasure to welcome you. A heartfelt welcome goes to our campus director, the patron of the symposium, Reverend Father Dr. Joman Tamanna, whose guidance and inspiration drive the success of every campus initiative. A hearty welcome to you, Father. It is with great pleasure that I extend a warm welcome to our finance administrator, Reverend Father Stanley Joseph, whose support has always been pivotal in making every event possible. Welcome, Father. We are honored by the presence of our distinguished guests, Ms. Timfia Gogia, Principal, Christ Polytechnic Institute. Thank you for gracing this occasion. On behalf of the entire Christ family, I extend a warm welcome to you, madam. A special note of gratitude to Guj Coast Gandhinagar, our generous sponsor, and GBRC, our advertising partner, for their unwavering support. A special welcome to the judges, senior professors, and faculty members of various colleges across the nation. A warm welcome to each one of you. I wish to recognize and commend the efforts of the convener, Dr. Neha Jungbari, and co-convener, Dr. Jagrut Tripathi, and the entire organizing team for the dedication that they have and the hard work they have put to make this symposium a reality. We also thank the media representatives for their coverage of this event. Finally, I would like to extend a cordial welcome to all my dear and esteemed members on the staff of Christ College, distinguished guests, delegates, and my very dear students. As we embark on this journey of exploration and learning, let me leave you with the inspiring words of Marie Curie. We must have perseverance and, above all, confidence in ourselves. We must believe that we are gifted for something, and that something must be attained. Welcome once again to the 15th National Science Symposium 24, organized by Christ College and sponsored by Guj Coast. Thank you.
Thank you, Principal Ma'am, for your welcome address. Plants require care and attention, much like relationships. By entrusting someone with a living plant, you are acknowledging their ability to care, love, and nurture. The saplings are a symbol of our gratitude for your support and encouragement. We aspire to learn new ideas and opportunities from our respected dignitaries present among us today. They have worked immensely hard to reach to their position, and we are very fortunate to have them with us today. I would like Principal Ma'am to welcome Professor Shashidhara by presenting a token of gratitude. I I would now request Father Stanley Joseph to welcome Dr. Madhvi Joshi with a sapling. Thank you, Father and Madam. I would request Mr. Jagrat Tripathi to welcome Professor Girish Bhimani with a sapling. Thank you, sir. As petals unfold to greet the dawn, we too must embrace the beauty of transformation. For in the crucible of challenge and change, our character is refined, our minds expanded, and our spirits strengthened. It is our privilege to be guided by a visionary leader who embodies the spirit of resilience, radiance, and transformation. I thus request Reverend Dr. Father Chaman Thomanna, Director, Christ Campus, to share his insights with us today.
Dr. L.S. Shashidhara, Dr. Madhavi Joshi, the keynote speakers for the Science Symposium 2024. Dr. Girish Bhimani, the former Vice Chancellor of Saurashtra University, esteemed faculties from the Saurashtra University, Reverend Father Stanley, Dr. Juan Fernandez, Dr. Nymphia Gogia, Dr. Neha Jangbari, the convener of Science Symposium, Dr. Jagrat Tripathi, the co-convener of Science Symposium, esteemed faculties and student delegates from across the India. I'm honored today to welcome you all to this temple of learning, where we believe learning is beyond textbooks. We believe learning is beyond scoring academic marks. The campus believes learning is not getting into a profession, but growing to contribute to the world. That's the only reason that this Science Symposium is the 15th edition. You know, mostly we get bored with when we see for the first time, second time, when we do it for third time. But if this is being sustained for 15 years, over a decade, it simply means that it is being cherished by the lovers of science and technology. And credit goes to the entire team of science faculty of Christ Campus. Let's give them a big round of applause. On this day, I feel privileged because across the country we have around 500 participants. And for that, the team of the Science Symposium has worked hard. I would appreciate you for registering yourself to be a delegate in this symposium. But at the same time, the effort that's being taken by the team is remarkable because it was not easy to get registrations. Now, I want to bring your attention to that reason. To tell you very, very frankly, they were very skeptical and doubtful about the number of registrations because the interest in getting into critical thinking, the interest in having curiosities in what you see is slowly diminishing. Whereas people, as young learners, start thinking, getting into academic scores, getting into more earning jobs, the priorities have been shifted to a short term rather than a long term. If you have heard about a new terminology that has been widely discussed and being accepted, is brain rot. Have you heard about? Yes. In the year 2020-24, Oxford Dictionary has adopted this as mostly wide accepted. No, brain rot. It's a phenomenon that happens on the youngsters mostly because of the various factors like social medias, gadgets, and less interest in thinking and getting into involving into development of the skills. My dear delegates, we bring eminent personalities like Shashidhara Joshi and Professor Bhimani and all these great people are being brought here so that you get motivated how they have built up their life to this stage. And Science Symposium focuses on the curiosity of the youngsters. And secondly, it focuses on the critical thinking. My dear students, it's very easy to score. Don't tell me it's very tough to score. You study on just for a previous day, a few days, work hard, you will get a good score in the examination if you are intelligent enough. And next day of the examination, you will forget it. You won't remember it for life. Whereas, to learn something for life, it's very hard. It's tough. That is where the role of such symposiums takes place. That beyond textbooks, it makes you to think. If you have a good critical thinking skill, if you have grown with curiosity of minds, there you will be a person who will be contributing to the world and to the nation. Or else you will contribute only to your mark sheets. I wish all the best to every delegate who have participated, and I congratulate you for the bold decisions that you decided to think out of your textbooks. I congratulate the entire team of Science Symposium 2024, the convener, Dr. Neha, the co-convener, under the leadership of Principal Madam, and the entire team of science faculty for the effort that they have taken to bring the young, vibrant, talented, enthusiastic young scientists from across the world, across the state, country, so that you exchange your ideas. It will become a learning experience for you. I'm grateful to our keynote speakers, a guest of honor. The entire fraternity who has supported us, especially the science fraternity in the state of Gujarat. I congratulate and thank everybody for the effort that you have put in to be for this day, to make it as a remarkable day where the young scientists will exchange their ideas. Wishing you all the best. God bless.
Thank you, Father, for inspiring us with your vision and directorial address. In the real
चश्मदीद गवाह हूं ये साइंस सिंपोजिया का, और इसी कॉलेज में इस बात का भी मुझे फक्र है। और आज हमारे बीच दो ऐसे इंसान हैं। फिजिक्स मीन्स व्हाट? जीवन, लाइफ। Beyond the life, that what you have to learn, or you are getting some knowledge, how to live the metaphysics in this campus, or I can say that you can learn it from Christ family. कुछ कुछ बातें ऐसी भी होती है जो मेरे दिमाग में भी अब तक नहीं है। पता नहीं दूसरों के बारे में। हम परमात्मा से विपरीत जा रहे हैं। मैं भी इनमें से एक हूं। हर कोई पुरुष को परमात्मा ने बाल दाढ़ी दिए हुए हैं, वो सब साले कटवाते हैं। अभी ये सोचो, नाउ साइंटिफिक थॉट्स, इफ द मैन विथ क्लीन सेव, गुड फॉर लुक। ऑन द कॉन्ट्रेरी, अगर महिला दाढ़ी मूछ वाली हो तो सही बात है। सोचो, when we go for any test, either CBC, blood sugar, urine routine microbe, till the doctors of the country like India believe the data of ancient time. पुराने जमाने के जो थे वही डेटा आज भी दिखा रहे हैं रिपोर्ट में के FBS in between 90 to 120, PPBS 120 or 140 to 160, that is good. तो मैं कभी कभी पूछता भी हूँ डॉक्टर लोगों से कि दुनिया कहां से कहां आई, और ये साला मेडिकल साइंस है, वही का वही है। There is no change. तब जाके ऐसी सोच आने के बाद I am reviewing the literature. And what I found, क्या देखा मैंने, APC, American Physician Conclave, something like that. उन्होंने बोला कि nowadays अभी FBS 200 तक हो तो चिंता की कोई बात नहीं। वो IMA की, इंडियन मेडिकल एसोसिएशन की वेबसाइट पे जाके भी आप देख सकते हैं। Then I talk to such things when the person is pursuing his vascular surgery in Vellore. Then what he says, that is true. अगर कोई पेशेंट हमारा है, उनका ऑपरेशन किया हुआ है और हमें if the nursing staff and paramedical staff is disturbing us, then we directly say to them, if blood sugar is up to 250, don't call us. Then I said, why this is so? तब उन्होंने बताया, due to change of food pattern, due to change of agricultural product, earlier days that is 100% organic, nowadays 100% organic, that is full of fertilizer, pesticides, air pollution. Then again, I try to think over it. And I experienced on myself, because nobody is believing me what I am going to say. That's why जो कोई भी प्रैक्टिकल करना है वो मैं अपने पर ही करता हूं, क्योंकि आई एम द बेस्ट, आई एम द बेस्ट। पिछले 2 साल से आई स्टार्ट टू ईट मिलेट्स ओनली। I don't put a single piece of wheat inside my mouth. And I get drastic change. In my blood, the capacity, the self-confidence, mental strong. That's the experience what I got. Though I am eating millets only since from last 2 years. So it is in a span of 730 days only. That's why my entire Christ family knows, वो जानती है। जो बोल दिया सो बोल दिया, वो तो करना ही है, any how, in any situation। इस तरह का एक कॉन्फिडेंस भी बिल्ड होता है। तो ऐसी बातें हैं, इनमें आप सोचो। बिना सोचे फादर जॉर्मन ने जो बताया कि विदाउट थिंकिंग ऑन इश्यू, वी कांट डू एनीथिंग। अगर खाना भी है तो हम पहले डिस्कशन करते हैं, तो सोचते हैं कि आज शाम को ये खाएंगे। तो on each and every step of life we have to think. And as a students of science, we have to analyze it. After analyzing all these things, you are getting the best output. And once you get to start thinking over it, I have no doubt in my mind that you all are stars of the galaxy. इतना ही नहीं, देश के अच्छे वैज्ञानिक भी बन सकते हैं। इसी बात के साथ आप सबको बहुत बहुत धन्यवाद।
Thank you, sir. It's always indeed pleasure to hear from you. Now, I may request Principal Madam to felicitate Professor Girish Bhimani, sir, with a memento. Professor L.S. Shashidhara works as a professor in Faculty of Biology, ISER Pune, and currently deputed as a Center Director at NCBS Bengaluru, which is one of the most premier research centers for biological sciences in India. He is also a visiting professor at Ashoka University, leading private and liberal universities of our country. Sir is a renowned biologist specializing in genetics, molecular biology, and evolutionary biology. He did his undergraduate and postgraduate studies at University of Agricultural Sciences, Dharwad, India, and holds PhD from the University of Cambridge, UK. He received a Shanti Swarup Bhatnagar Award in the year 2008, known as the Nobel Prize of India. He is also a recipient of other prestigious awards like J.C. Bose National Fellow Award, as well as elected Fellow of Indian National Science Academy, India. In 2018, Shashidhara sir was elected an associate member of the European Molecular Biology Organization, making him the third scientist from India to join a group of 1,800 researchers. Sir was also a president of International Union of Biological Sciences at 33rd Assembly of IUBS at Oslo in 2019. A great personality makes everyone feel energized, just like a flower's fragrance that freshens up the complete surroundings. Sir, it is an immense honor to have you with us today. May I request you to come up on the stage?
Very good morning to all of you. Thank you very much, Christ College, the entire team, principals, directors, all the faculty, for giving this opportunity to visit this college. Very impressed with what you're doing. I heard a little bit about the journey of this college in the last 26 years now. And I'm very impressed. And of course, Madhvi Joshi, a collaborator, a colleague, and a friend, made this possible. Thank you very much, Madhvi. And also my first, more or less second visit to Rajkot, although first time I'm sort of going around and seeing the city. Again, it's a very nice place. Those who have come, the students and delegates from outside Rajkot, please do go around, visit the city. It's a very interesting, and it has a lot of history. Mahatma Gandhi studied here, There's nothing, great place than visiting the place where he lived or where the school that he went. And you should visit, all of you. Okay, so quickly, I'll not, I think I have 45 minutes if I'm correct. I'll try to sort of stick to the time. I thought, what should I talk, in a gathering like this? You're all students of science coming from different disciplinary background, physics, chemistry, mathematics, biology, computer science, and earth science perhaps. Then I gave some 2-3 different titles, and the organizers have picked up one of them, which is this title. So, we keep talking about, when we talk about science, history of science, who accomplished what, we start with typically, maybe in mathematics we start with Pythagoras, or in physics we start with Aristotle, or later we talk about Galileo, then Newton, then Einstein, and perhaps it stops. Or when we talk about Indian science or scientists of India, there's nothing like Indian science. Science is one, it's global, but there can be scientists from India or scientists from Europe or scientists from America or Japan. So among the Indian scientists when you talk about, we talk about Raman, J.C. Bose, perhaps S.N. Bose, those who remember his work or had read about his work. And in modern days, Professor C.N.R. Rao, a famous chemist. But there are so many people who have worked in India who have contributed to the growth of this place. And they are scientists, use scientific knowledge, develop innovative methods, innovative ideas, innovative products, and have contributed to. If you are living in a very comfortable life today, it's because of the people who worked in the first 75 years of this country's history, since independence, 1947. So that's the journey I'm going to talk about today. Right? I'll use a few anecdotal examples. There are no big heroes here. Everyone is a hero. Everyone is a person who contributed to this, in that team. It's a teamwork, it's collaborative work. Sometimes some names may be, attached to this, but it is largely a collective effort of many, many scientists of this country. You all school kids, college kids, I guess, in the audience, most of you. I don't know how many of you know what is a ration shop is. How many of you have actually visited a ration shop here? Well, you're all much older. My generation, I used to go and stand in the queue for 2 to 3 hours to get rice, sugar, and kerosene. I don't know how many of you use kerosene today at kitchen. And we don't use any of those today. We're in a very comfort zone. However, still there are about 30 to 40% of Indian population live with ration food. And they, of course, they may not depend on kerosene because kerosene is almost abolished, but there may be other ways of cooking. But still there are a huge population which need upliftment. So there's a lot, there's a journey is still in progress, work is in progress. We have come a long way, but we still have to go a very long way. Okay? So that's what I'm sort of talking about. Where's my... So, just to mention that why it is important to study science, why it is important to understand the knowledge using scientific methods and use this for applications, right? As you all know, science is simply not physics, chemistry, mathematics, or biology. Science is a collection of methods. There are what's called rational methods. It basically goes through a series of steps. You make an hypothesis. Hypothesis can be based on the prior knowledge, certain observations that you make, or something you have read from others, or something you imagine intuitively, and then you want to validate, you want to verify, you want to test, and then you do a series of more observations or experiments, and that's how you come out, right? And this is exactly what you do. By both observational studies, you do make more observations, or you also do what's called experimental work studies, right, or pre-designed studies. And that's how the science progresses. And it is validated again and again, not one time. You may validate, you may publish, but it will be peer-reviewed by your own community people. But that's still not enough. Once it goes to a journal, it's published, more people will read it. They try to use that knowledge to formulate new hypotheses or to advance the areas in which they are doing science. Sometimes they may feel that, oh, it didn't work. They say, whoever has published this perhaps done a bad job. And then we have to redo certain things. So it's time, unless the so-called information withstands the test of time again and again, using variety of different scientific methods, it will not be converted into knowledge. Everything what we normally say in the beginning, it's only information. Only after a very long time it becomes knowledge. For example, Einstein's theory of relativity in 1905 when he published, it was still only information. It took 20 years to become knowledge. Darwin's theory of evolution was a piece of information for 50 years. Mendelian genetics was information for 50 years. It became knowledge only about after several decades, right? So typically it takes very long time, used to take very long time, perhaps in the modern days, because more scientists and also, information flow between scientists is so fast, almost real time, it's much faster. The reason I put this, the previous one, it's one thing you have to be very careful about science. There are a lot of myths around science many times. People use a lot of fake information saying that it is scientific information, right? People imagine that whatever they have imagined, whatever dreamt is considered as science. Science, as I told you, it has to be validated multiple times before it be considered as valid knowledge. And what science can do is beyond anybody's human perception, right? So all our sensory organs have certain limitations. We evolved as part of the animal kingdom over a very long time. The beginning of animal kingdom is close to about 1 billion years, right? 100 crore years. In 100 crore years, only recently, about 200,000 years, so-called Homo sapiens sort of evolved. But the human species, or the Homo genus, is about 5 million year old, right? 50 lakh year old, from the ancestral common ape between chimpanzees and human. And our cognitive abilities, our brain has evolved over a very long time, because animal kingdom is the one where the brain started evolving, the neurons and multiple neurons, single neuron, multiple neurons, and then billions of neurons like in human brain, right? And still we have a lot of limitations. You cannot see beyond certain distance. For example, if you look at the sky, all the stars are exactly the same distance from us. But each star from each other, there can be several millions of light years apart. We cannot distinguish that distance. We cannot distinguish anything larger than 1/4 of a millimeter in terms of size. If two dots are very close to each other, you consider it as one dot. When you see under a microscope, you can see that there are two dots. The third is the time. You cannot distinguish anything less than 100 milliseconds. If two events happen with a gap of less than 100 milliseconds, you consider one event, right? So all of these things are limitations to our cognitive abilities. What we have done is going beyond human perception using modern scientific methods. Very often it requires tools like telescopes, microscopes, video camera, fast video camera, and so forth, right? So, for example, all the 7 billion people on Earth, no one can, if they have not read a science book, if you have not read anything about Earth moving around the sun, they always think that it is the sun moving around us. Even today in our vernacular day-to-day language say, sun rises from the east and sets in the west. Sun is not rising from the east and resting in the west. It is we running around it, right? So, but that's what science has able to tell us. That is, it is not beyond your imagination, it is not beyond a community's imagination, it is not beyond a few billion people imagination. It is the imagination of every human being ever lived on Earth. And today's 7 billion people, we have, proved or showed what the real world is, right, with the help of scientific methods. So it's very important when you use scientific methods to address a scientific problem or a real life problem, health, water, food, energy, environment, biodiversity, whichever the problem you want to address, you have to ensure that whatever you do, it should be beyond your own personal imagination, opinion, thought, and so-called knowledge or information. It has to be acceptable across the community, right? Until then, you don't consider as valid information. So what comes in your WhatsApp, what you see in social media is not knowledge. It is only noise. It is only information. Unless it is verified, validated, it cannot be considered as, knowledge or valid information that can be useful. You may get hundreds of WhatsApp messages that the previous speakers spoke later about the health like diabetes and kind of thing. You may say, you do this, you will be cured of cancer. You eat this every day in the morning at 5 o'clock, you will be cured of so many diseases and kind of thing. I don't think you should believe any of those things. No, I'll take that. So there are two aspects to the science and technology enterprise. Science and technology are two different things. They are coupled, but still they are two different things. They are related. Science can happen without technology. Technology can happen without science. The best example is that technology without science is invention of wheat, invention of starting of agriculture. The humanities have developed so many things, controlling the fire. So many things they have done over, thousands of years, without understanding the causal relationship between what they do and what happens, right? That's simply technology by trial and error. Only when you explain the causal relationship and then try to improvise based on the knowledge of the mechanism, some technology, then it becomes science-driven technology. Sometimes science drives new technology. For example, your mobile phone is based on the modern understanding of physics, electronics, and the theory of relativity and so forth, right? But what happens is, because science can drive good technology, and technology helps, for example, the telescope is a technology which helps us to pursue science much more comprehensive way, right? So in a way, both are dependent on each other, but at the same time, they are two different things. So you have to be very careful in today when you want to develop a new technology for health, agriculture, or environment. Make sure that it is dependent on the science, right? Simply by trial and error, you just see something. Don't think that it may work all the time. It may work one time because of your observation. Unless you understand the causal relationship, you'll not be able to scale it up. You'll not be able to make it a viable technology. And just for the historical thing, earlier days it used to take very long time to convert knowledge into a useful technology, right? And today, of course, it happens almost in real time. Just to give you two examples, using the life science example, Darwin proposed in 1859 theory of relativity, theory of evolution, and for a very long time, no one had understood it, no one would be able to validate this, and it took close to about 60 to 70 years to re-establish that it is a valid theory. And around the same time, people were comparative physiology emerged. Comparative physiology is basically physiology comparing different animal forms. For example, all mammals have similar kind of physiology, particularly reproductive physiology. So all the birds and mammals have warm-blooded, so they have a certain kinds of physiology which is different from, for example, reptiles, which are cold-blooded, right? They do not maintain the body temperature with the help of the metabolic activity, right? So this is the comparative physiology means. One of the things that also happened was the beginning of the 20th century was also beginning when you started looking at the molecular level, particularly the chemistry and biology integrated, and a new field called biochemistry started. The biochemists identified proteins as the catalyst of reactions, chemical reactions in the biological system. They found out that there is something called insulin. Insulin is required for glucose metabolism. And they also found out that insulin as a protein required for glucose metabolism across all mammals. And around that time, until then, there was absolutely no treatment for diabetes. Unless you control the diet a little bit, for absolutely no treatment, irrespective of how much anybody can afford. There was no treatment for diabetes. Whether the poorest of the poor or richest of the richer, they had to suffer the same way. And people started extracting insulin from mammals, from slaughterhouses and everything, and lyophilize and put it in a small vial, and now started giving it as treatment for diabetes, particularly type 1 diabetes or severe insulin deficiency. And that became a treatment for diabetes, but because you get a small amount of insulin from a large animals, it was not so viable solution. It was only available for few people and became very expensive, so it has become most like a rich person's medicine, right? And indeed, for about 70 years, diabetes was considered a rich person's disease because you couldn't afford treatment, right? And with better understanding of biology, the chemistry of biology, that is what called chemical basis of life. DNA was discovered, DNA double helix, structure was discovered, how information is coded, decoded was discovered, the process was discovered, transcription, translation. And they found out that the chemistry of life is exactly the same across all life forms that existed on Earth, right? The bacteria to human. And now we take a piece of DNA, codes for insulin protein from human, put it in bacteria. We can make huge amount of it. In this kind of a hall, you can make kilogram quantities of insulin. Now insulin is so cheap and affordable. Most government hospitals, they give free of cost, right? Now suddenly, there was an equity earlier because of no treatment to anyone. Then there was a treatment available, but it was unequal because only rich people could afford. Now everybody can afford. That's the essence of science. But it took 100 years, right, to get to this, 125 years old. But if you look at in modern days, because of internet, because of our information technology, the way we communicate with each other, not only we communicate through text, we also communicate videos, we communicate through images, right? That help for information to transfer in real time across the globe. And look at how it has helped to address the COVID-19 problem. 2019 December, we came to know that there's something called a new SARS virus which is infecting people. People are dying of unknown, influenza, fever. By the beginning of 2020, we already knew that it is SARS-CoV-2, it's a coronavirus-like virus, and then how virus infects, what happens to the lung cells, how it replicates, how it comes out, how we can detect, how it spreads, and how people react through cytokine storm or heavy inflammation, how inflammation affects your lung, and all that thing were done. And within 12 months, we already had some drugs and more importantly, vaccines. By 2021, we started vaccinating the populations across the world. And by end of 2021, more or less, the COVID problem got over. Although we lost lives, many people died, many people lost their livelihoods. It still, given the population size of this world, given the increased mobility of the populations, people move around, it's carrying the virus, given the fact that large cities have very high density of people, in spite of all of these things, we have been able to contain the COVID problem in 2 years. Although we lost few million people, but it is what could have happened if we didn't develop vaccine within 2 years is unimaginable, right? We would have lost many people. Earlier days, for example, when there is a cholera outbreak or particularly plague outbreak, for example, sometimes entire town used to get completely wiped out, right? Because there was no way to control the infection. But now we've been able to do it because of not only we had sufficient understanding of the biology, chemistry of biology, at the same time, information, every discovery happened around that time was immediately transferred across the globe. More and more people could participate in solving the problem. Okay, so this is a placeholder, just to tell you that I'm also a researcher. It's not that I'm here only to talk about some history. I work in the area of so-called developmental biology, where we study how from a single cell zygote is what is given to a fertilized egg, right? Egg, once it's fertilized, is called zygote. It's a single cell stage is called zygote. when it becomes a multicellular stage, it is called embryo. In human medical terminology, it's called fetus. In zoological terminology, it's called embryo. Right? So how from a single cell zygote you get multicell individuals such as this, right? And this individual has 50 trillion cells, well organized, well positioned, so that all of you have eyes exactly in the same position, ears exactly in the same position, and you have arms, legs, everything, internal tissues exact to the same size and shape, proportionate to the body size. All that thing happens, and then of course the physiological connections in all tissues and organs, so that you function as one organism. Right? But it is a very complex. It happens over 9 months in humans. In Drosophila, for example, in insect, it happens in 24 hours. Or, actually it's 12 days. But there are 2 stages into the life cycle of Drosophila. First, it becomes larva, and then becomes an adult fly. So we basically were studying the very different aspects of developmental biology, particularly spatio-temporal gene expression, and how they are regulated, how very different organs and tissues are positioned and attain specific size and shape. That's a work still ongoing in the lab. But many of these things also related to cancer. What happens during development is tight regulation of cell division, right? For example, if you have to have an arm of this size and shape, certain number of cells have to be there, and it should not be too less or it should not be too more, right? It should be exactly the same. And if one cell dividing has to have so many regulatory steps, because the internal biochemical properties should remain the same when 2 daughter cells are born. Amount of DNA should be the same, quality of the DNA should be the same between 2 daughter cells. Given all of these things, even a single cell organism like yeast or amoeba has to go through several layers of regulation before they divide and become 2 cells. Think of millions of cells dividing, and they have to make sure that they all have synchronously divide. At the start at the same time, stop at the same time. So there's a much more complex regulatory control. So these are the 2 things which we were studying over 30-35 years in my lab. And what goes wrong in cancer is this one. This control, the cell division goes wrong, becomes uncontrolled cell division. So developmental biology and cancer are extremely and closely related. Whatever understand development will also be useful for understanding the cancer, because what happens in cancer is something which normally happens in development but doesn't happen in cancer, which is loss of control, right? Gene regulation and cell division control. So these days I'm also working on cancer. And many other things. We also work on infectious diseases and so forth. Okay, coming to the main part of today's talk. I think I will only spend 15 minutes and about 30 minutes I'll do this. Then we'll all exciting to hear Manvi Joshi after this. So I've written less known stories, unimaginable impact. When we talk about Indian science, we all talk about, first thing is how Indian science has contributed what we are today. First is Green Revolution, which is definitely one of them. Second is White Revolution, started in Gujarat, what's called Milk Revolution, which is also called Nutrition Revolution. It is not white or milk, it is nutrition, which is most important aspect of our health. So food and nutrition is the first important thing. Once you attain this security, you have a more confidence to do many more things, right? Then many things happen. IT happen, space happen, and many more things, right? So we'll talk about stories which are beyond all of those things. I'll talk about nutrition to some extent, but beyond the well-known stories like space, IT, and other things. But although I may tell you some of those stories, the beginning of some of the big stories, which are again not celebrated in India because less known to the public. So just to give you the historical background, how it all started. So the so-called modern education, which you're all enjoying today, is the beginning of that is around 210 years ago, when Presidency College was established in Kolkata, and then many other colleges, universities were set up. But initially it was meant for teaching Indians the English as a language and law some administrative and accounting principles so that they can work in the government sector and help Britishers to govern the country. Because you have millions of people and few thousand British here, and you need an intermediary between the locals and the British, right? But they are, of course, of colonial interest. They are not interested for India, whatever they are doing. It is not that they wanted to educate India, they wanted to educate few Indians to help their colonial interest. But interestingly, what happens, that's exactly what education is all about, right? Education is to open your mind. Education is not to learn certain skills, right? It's open your mind. When you open your mind, you start seeing the world. You start seeing the world of the interesting part of the world and also saddening part of the world. One of the saddening part of the world is inequity. India still has huge socio-economic inequity, source oppression and so forth. But at the same time, the people who learned in British-run schools and colleges, they found out that what is being taught is not being practiced in India. For example, human rights, democracy was already much more matured and taught in Britain. You know, Britain, democracy started in 17th century, middle of 17th century, right? Whereas what they were following here was not democracy. Human rights were given maximum importance in Britain, but they are not giving the same importance in India. So that aroused what's called nationalism or patriotism, because the people went through. In fact, all the people, the first generation freedom fighter, even the second generation freedom fighters, are all the students of the same colleges, and Mahatma Gandhi, Sardar Vallabhbhai Patel, or Balagangar Tilak, Gokhale, even some of the reformists like Raja Ram Mohan Rai, Mahatma Phule, whomever you talk about, they're all studied in the same system, but they actually, the purpose of for which they were given education, it's in a way they went opposite to this, right? They started opposing the British rule. And they also started their own education institution. Like for example, BHU, Aligarh Muslim University, Indian Institute of Science, Indian Agriculture Research Institution, or Cultivation of Science. All of these organizations were started by Indians. And but what they really understood is importance of science, importance of modern education. That is undeniable. It doesn't matter whether it came from Europe or came from somewhere else, but there is a value to that education, value to that knowledge, value to the way knowledge is being produced or discovered. At the same time, they didn't want the purpose for which education is being given. And when we became independent in 1997, we have a big challenge. We are a country with absolutely no self-sufficiency in food. We didn't have any manufacturing facility. We didn't have the deep pocket, wealthy industrialists to build new manufacturing units, give jobs, to create employment. Even more problem was there were no skilled resources. There were no literary people. Literacy was only 10% at that time. With 350 to 400 million people with 10% literacy, and not literacy means everybody can, read, write long essays or understand the science or engineering and so forth. You build a nation, you need people. Nation is nothing but people, right? Even if you want to build buildings, you want to build roads, build dams, right? You need people. Or you want to develop new agriculture methods, you need skilled resources, technocrats, right? So obviously education is where we invest first. Like even today, an auto rickshaw driver or a daily wage laborer, they somehow try and put their children in the school so that next generation will not suffer the way they are suffering, right? Exactly the same thing at the national level too. The founders of modern India, particularly at that time, Nehru and Maulana Abdul Kalam Azad, the first education minister, the ones who started the whole new set of institutions, starting with IITs to universities to very different research institutions, engineering organizations, funding agencies, all of course, what happened in the first 20 years and what happened later in the book. So you create human resources first, and those human resources are the ones who contribute to building the nation. That's exactly what happened. So these first 25 years, we educated people. Next 25 years, those educated people contributed to green revolution, milk revolution, or nutrition revolution, developing space research, atomic energy research, IT industries, IT resources, and so forth. And that's helped in the next 25 years 1921 to 91 onwards, when India declared so-called liberal economy, and what we are enjoying today, so-called comfortable life, and it's all because of what happened in the first 50 years. Next 25 years is the so-called modern development. And now we are moving into the fourth quarter of the century since independence. Now the question is what we do next, right? So what we do next, there are multiple problems. Climate change is a problem. The loss of fertility in the soil is a problem. Variety of different problems we are facing. All of these needs to be addressed. So new innovation has to happen. New knowledge needs to be generated. And that's the role that new generations. In fact, what the people in the first 25 years of Indian independence, they are the founders of so-called modern nation. The same way, the students of this quarter, right, between the next 20 years or so, are the ones you're going to build the modern India, which has more sustainability, equitability, and equity in access to resources, access to health, access to food amongst all the people, because we still have not achieved equity. So all of us are proud that India is one of the largest GDP countries, perhaps now fourth or fifth, depending on how you count what is GDP. But at the same time, if you look at per capita, we are nowhere close to even the first top 100 countries, right? We are at the bottom. So it was most important is bringing equity, sustainability, and climate resilience, climate mitigation, related, solutions to the modern world. And for that is what the future citizens have to worry about. So in that context, we have actually initiated many new educational initiatives, because again, the next generation has to be prepared for their time, right? So education is all about training the people for their future. We may have come, I studied 50 years ago in the school, and now I can't go back to school and try to teach something what I learned, which I learned for yesterday, not even for today. You people are the students of, day after tomorrow, or the citizens of day after tomorrow. You need to learn very differently. So that's where these initiatives were set up. And these initiatives are meant for you to develop analytical ability, innovation ability, critical thinking, self-learning ability. All of these things are more important than the content of what you study. Doesn't matter how much you remember in biology or physics, you need to develop these transferable skills, right? Because your information is already available. For us, information was not available on mobile because there were no mobiles. We had to go to the library and read some books, but how to integrate knowledge was a problem. So integration of knowledge was not happening. The computer was happening, through reading multiple books in our brain, and with the help of other teachers and collaborators and co-students, right? So obviously, some amount of effort is to go to memorizing the information. You don't have to memorize the information, right? So you can develop very easily some of these skills, which are the most important skills that is required for today's world. I'll skip all of these things. I'll go to quickly the 11 stories. Maybe for 4 or 5 of them I'll narrate. First one is I'll start with something happened very close to this place. Anand, I'm sure you all know, Amul thing started, it's white revolution, milk production, cooperative milk product unions. It was more of a management solution to a problem, agriculture problem. Dairy is also an agriculture, part of agriculture, right? Later, science and technology started. First thing was, we were importing baby milk powder. First thing is, Indian children, infants, not children, infants getting nutritious milk was always a problem. And that has an immediate impact on our cognitive ability and the physical abilities, right? So children were stunted, and cognitive abilities were also much weaker, given that they didn't have access to nutritious milk. Baby milk powder in Europe was very common. And Kurian, who was the founder of Amul, he imported a baby milk powder making machine from Switzerland, but it didn't work for Indian milk, because Indian milk was mostly buffalo milk. Even if it is cow milk, it has more fat, buffalo milk has even more fat, and this machine was not useful for making baby milk powder. Then a few engineers and physicists in CFTRI in Mysore, they collaborated with Amul, and they make Indian version of the machine to make the baby milk powder, and that enabled large amount of surplus milk that is produced during certain seasons, which you cannot distribute easily, and convert into baby milk powder and distribute across the country. The shelf life is longer, so they're easy to store and distribute to the country. And many hospitals, particularly government hospitals, used to keep Amul baby milk powder for children of parents who cannot afford to buy that in the market. Right? That helped improving the cognitive ability of the population. Second was, even when during time when you have to give fresh milk to children, now it is a children, infant is different, children different, the requirement are different. Children also require nutrition food during early growth for their both for physical and cognitive growth, right? Because brain uses a lot of energy. I'm sure all of you know, with billions of neurons. But it still uses much less energy than a computer. Right? But again, the milk initially was directly supplied in open, cans, and later the bottled one came. The bottled milk was, what called pasteurized milk was being supplied. But it's still not enough. You couldn't take it to longer distances. For example, from Anand to Gan to Rajkot itself was going to be very difficult if it is a bottled milk. Then in Baroda, there is the Indian Petrochemical Research Center, and people like Varadarajan and Shivram, they're two famous, chemists. They are the ones who knew Korean, and they were discussing over, some dinner, saying that, Korean was saying that, it was so easier if I could supply this milk to children far distances, so they can also benefit from availability of, good nutritious fresh milk. And these people thought, okay, we are chemists, why don't we make certain kinds of packing material which is easy to carry, and also milk can stay for longer even without refrigeration, because there was no refrigeration in India at those days. Even in a shop, they never used to have a refrigerator, forget about it at home. Most of us are so-called, in today's context, you call them a lower middle class. At that time, we were even could be upper middle class, you wouldn't have afforded a refrigerator, right? So they developed this packing material using food grade new type of plastics, where how you can fill, so milk is filled and little bit of nitrogen is added in this one, so that milk remain unpolluted, uncontaminated, and also remain fresh for a very long time. Right? And that's how the so-called nutrition revolution began. I always make a joke. I don't have a concrete causal relationship to be established, but it's very obvious there's a causal relationship. You have good good nutrition available during infancy and child growth, you will do better in your adult age. India winning cricket matches, Indians doing very good in very different other domains of life, was exactly 15 years after our nutrition revolution. So you can establish the causal relationship. So plant tissue culture, all of you know plant tissue culture. Nowadays even farmers have their own plant tissue culture, particularly educated advanced farmers, progressive farmers, they use their own farm and develop plant tissue culture, tools, and then distribute tissue culture plants or seeds or seedlings to other farmers. It's a $1 trillion company. It's all started in India. After independence, Panchana Maheshwari was a professor in Dhaka University in Bangladesh. He shifted back to Delhi, joined Delhi University, along with his few students like Johari, Mohan Ram, and others. He actually established a tissue culture lab. And for them, it was the fundamental science. The students of biology would know that all animal cells go through cell division, and then they differentiate. When they differentiate for terminal differentiation, you become neuron, muscles, liver cells, and so forth. But they don't de-differentiate. But that means they lose the ability to divide again and contribute to something else. They are one direction, one destination. Whereas plant cells can de-differentiate. It was known for some time. That's how you can do grafting, right? It was known for 200 years that plants can de-differentiate and re-differentiate into a whole new plant. So they want to understand why plants What is the mechanism by which they de-differentiate and redifferentiate? And that basically established the whole technology for plant tissue culture, which is now the entire world is benefiting, not just India. Another is, another very heartening story. You all have donated blood, I'm sure. Your blood is collected in a blood bag, goes to a blood bank, get tested and stored for up to 3 weeks. And any needy person requires blood transfusion, it is given during surgery or during accident when there's a heavy bleeding happens, right? And that saves millions and millions of lives every year in a country like India with 1.5 billion people, right? But just about 30 years ago, we didn't have blood banks, we didn't have blood bags. A few places like Mumbai and Delhi had blood bags, not even blood bank, because there was not enough. Blood bag was there for keeping the blood for a few days, not for a few weeks, and was imported from UK and very expensive, and we couldn't afford. Most of India didn't have the ability to keep the blood for some time and give it to needy people. The way we were doing it, like in Indian old Hindi movies, you see that the donor and the receiver are sleeping next to each other, and the donor's tube goes to the receiver, and the blood flows, and then they show drop by drop, the emotions builds up, right? And the climax builds up in the movie. And the Sri Chitra Tirunal is also a hospital and a research institution. A few doctors and the chemistry people in the local university chemists, they worked very hard to develop indigenous blood bags, right? Exactly of the same quality, but at low cost. And finally, as you all know, the real, taking the product, taking an idea from the research place to the end users or end beneficiaries requires market-driven approach. That is well established. Even communists won't deny this, right? Market-driven approach is the best way to take this is the land of merchants, Gujarat. So without intermediaries, you cannot take farmers' product to end users. You cannot take any product to the end user, clothes or whatever. So, an IAS officer, Balasubramaniam, he resigned and he started the first Indian startup called Penpal at that time in the early 80s. And he actually converted it into a manufacturing unit where he can develop a standardized way of producing same quality product, take it to the market. Because the most important aspect of production is you cannot batch to batch variation should not be there, particularly when you're using this for medical purposes. And now India is the largest producer of blood bags in the world. India exports to 80 different countries, right? Billions of people are being served with the help of, all of them are still alive. You can go and meet them and salute them. And no, they are never heard of in outside the general public. We celebrate few people, mostly politicians, we celebrate for transforming the country, but we don't celebrate the names of these people. I'll skip this. Indian pharmacy is one. This skip this also in the interest of time. This is another interesting story. So, India is the origin of basmati is in India. Every plant, every animal has its own geographical origin, and Indian basmati, Indian rice itself is origin in India. It's called this way. It's called Riccia indica, the scientific name of rice, right, paddy. And among them, basmati rice, particularly the one particular basmati rice has a geotechnical, geological tag. Is called Garhwal basmati, which grows in the Garhwal area of Himalayas, the lower Himalayas, in Uttarakhand mostly, and also somewhat part of other Himachal Pradesh. And that basmati has a big demand in the world market. So Indian basmati is being exported, to all those places. But sometime in the 90s and 2000, around particularly in the beginning of 20th century, the Europe stopped importing, even Middle East stopped importing Indian basmati, saying that is all adulterated. In the name of basmati, you are sending simply long grain rice, bit of aroma, and they are not real basmati, right? So that there was a dip in the export that affected the farmers because they were not getting the right amount money for their product, right? And Rice Exporter Authority of India is a Government of India organization. It basically approached Center for DNA Fingerprinting and Technology, which is an institute in Hyderabad, which started with modern understanding of DNA-based technologies and how it can be used for medicine and agriculture. So, and one Nagaraju, a scientist working on the biodiversity of silk moth, he was an insect biologist, but he took up this challenge and developed a DNA fingerprinting method to identify whether it is an adulterated rice or an authentic Gharwal basmati rice. And see, it was a simple technique. Now today's idea is simple technique. Any undergraduate students can develop a DNA fingerprinting method now. But those days were still 20 years ago, was still difficult. They managed it in about 3 to 4 years, spending about 5 crore rupees. And that led to, I don't know, I have a graph. If not, yeah, I don't have one. That led to increase in the export of basmati, because now you are using advanced DNA-based technology to label it, right, to authenticate the quality of the rice that you are exporting. So suddenly the export increased. Today, just because of barcoding, DNA barcoding, on an average, close to about 5,000 to 10,000 crore worth of basmati rice is being exported, more of it, to the world. So India's government, in the form of export duty, is getting at least 500 crore rupees, even assuming that is only 10% is export duty. So anywhere between 500 crore to 1,000 crore per year earning to the Indian government, which can be used for education, health, public welfare and so forth. All this happened spending 5 crore rupees. Which corporate will give you that much returns for a 5 crore rupee investment? And every year, it's not one time 500 crore. It's not 5 crore is converted to 500 crore. 5 crore is converted to annual 500 crore. That's what scientists could do. We all talk about IT revolution. We say India is all, modern India is because of IT revolution, all the fantastic cars on the roads, all the buildings, all the heavy, roads, dams, bridges, and nice airports, good restaurants. We all sort of give credit to IT revolution. To some extent it's true, that is a proximal, but how it all started, right? IT revolution didn't start overnight. It took close to about 60 to 70 years. Charles Babbage developed first computer in the world. He was at Cambridge. Cambridge University was training some people in computer science using diploma in computer science. There was no engineering degree in computer science, even in Cambridge. But India never had computers even to think about computer education, think about anything to do with computer. The first computer came to India in late 50s as a donation from IBM. Second computer also came as a donation to IBM. First went to ISA Calcutta, second went to TFR in Mumbai. TFR Mumbai scientists started thinking about how you can actually develop more, better algorithm, easier way of writing algorithm to make the computer to work. That is what called software, right? And they are the ones, theoretical computer scientists in mathematics department started working on new methods of writing algorithm, which actually changed many things in the way computers work globally, not just India. More importantly, the fourth computer, when it was bought, it went to IIT Kanpur. IIT Kanpur being an engineering college for undergraduate students, they are started immediately in 1964 an undergraduate program in computer science. 1964, India is, that's the second college in the world. First one is Purdue University started an undergraduate program in computer science. I told you diplomas, computer science started in Cambridge University. Second is Purdue starting an undergraduate program in computer science. And the second one in the world was India. Even in US, they had not started another one. And how can you imagine that in a country which poorest of the poor, still getting food as a donation, has only 4 computers in the country, how you even think that there will be use, so many jobs for these people when they come out of undergraduate degree program. That is the foresight of these scientists. What they were thinking was very, very interesting. So in those days, one computer for one job. If you are using computer for data analytics of, let's say, social data, you have to use a different computer. If you are using it for atomic energy, something related, you use another computer, right? And the computer algorithm also, once you run some algorithm, you can't do anything else. You have to decode everything and then upload another set of algorithms. And the computer scientists, the initial ones, particularly the mathematicians, there was nothing like computer scientists because there were no computers. They are all theoretical computer scientists. They were using pen and pencil. They were not using computers. They were trying to develop algorithms where Same computer can do multiple jobs, depending on which software you upload, right? And they had an imagination or foresight, not imagination, that tomorrow we need more software people than hardware people, because same hardware can do multiple things, but software people are the ones who have to tell the computer what to do. That foresight generated human resources for the whole world. They are the first generation, because we didn't have computers, they all went to US, developed IBM, Intel, Microsoft, Google, and now the whole world is enjoying IT revolution because of some of these unknown heroes from India. Actually, known hero, known people, but unknown heroes. There's a difference. Now, the last one, and I think I'll stop after this. There are many more stories, but the last one for today, and because we are waiting for Madhuri's talk. I kept the last one. I know students out here come from all over the country, but maybe from local, because you are coming to Rajkot. I thought of something closer to Rajkot. This is a story from Surat. Ahmedabad and Surat both. Vikram Sarabhai, we heard of, all of you heard. He started what's called space, program in India, the father of space program. He was also a fantastic scientist, physicist. Space is a technology oriented, but he was also a basic science person. And he was also very passionate about promotion of science in the society. So he started what's called Science Outreach Center or Science Activity Center in Ahmedabad, called Vikram Sarabhai. Now it's called Vikram Sarabhai Science Center. Earlier it's simply called Science Activity Center or Science Outreach Center. And he used to invite people from all over the country, scientists, to talk about their science, to talk about new interesting innovation in science or technology to general public. One of them, that continued even beyond Vikram Sarabhai. In the early 80s, a BARC scientist came to that place and spoke about lasers. Lasers were, very, very initial stages in early 80s. I don't know if your first laser became public knowledge through a James Bond movie in 1980s, when that person talks about what is laser and then use the laser to cut a gold chest to, of course, to steal the gold. It was, the very beginning of lasers. But this BARC scientist, of course, knew about lasers. They talked about the science of lasers. Also said, lasers can cut even diamonds. The statement that person made. That caught attention of two diploma students on Ahmedabad, some engineering college, and they, spoke a little bit more about this with this person, and they, again, thinking about how they can, get involved in this. They made their own lasers, they fabricate lasers, they actually tested it, and they could cut and polish the diamond. Then they went to Surat, and they had some connection, and they tried to convince people. It took about 2 years for them to convince diamond, jewelers in Surat to make use of the lasers. And then finally, some diamond merchants started using it, and turned out to be that it's very useful. Because the initial apprehension is, we're all used to doing things in hand, right? They are called handcraft, right? But if you use machine, will you get the same artistic control? Because, for example, when you sharpen a pencil, right? Many people still want to do it with their hand than using some other method, because you can have a better, shape, better sharpness, same strength as the tip of the pencil and so forth. That's called hand. Your artistic skills in your hand and your brain, right? But you don't want to give out to something else. But tools, we have the ability to use the tools as an extension of a hand. That's how we can use tools too. But laser is a completely new machine. They didn't want to believe in nation or trust laser. But anyway, Arvind Patel and Dheeraj Lal Kotaria, they convinced, and then they used, and they found out that they can actually use lasers exactly the same way they can use a simple, tool, knife or such kind of a tool. And they could actually cut and polish diamonds. And then it started spreading like anything. It became, until then, Indian diamond jewelry, so diamond merchants are only using cut and polished diamond for jewelry, embedding in jewelry. But minute polishing you have to do it to fit in properly, right? But not so much of raw diamond cutting and polishing. but all raw diamond cutting and polishing used to happen in Antwerp. Why Antwerp? Antwerp is in Netherlands. Netherlands are Dutch. Dutch are the ones who first colonized South Africa. All the diamond, most of the diamond mines are in South Africa. Used to go to Netherlands for cutting and polishing and trading from Antwerp, right? So it was considered the diamond capital of the whole world. When Indian diamond merchants started cutting and polishing using lasers, it became less expensive compared to Antwerp. So what happened, the raw diamond used to go to Antwerp, and Antwerp to come to Surat, and then cutting and polishing, right? And then go back to Antwerp for trading purposes. So Antwerp was still controlling point for diamond industry, trading industry. Then Nelson Mandela came. Nelson Mandela democratized South Africa, also came out of the shackles of the apartheid, and he didn't have any obligation to send the products to Antwerp, and it was easier to send to India because it was much way cheaper. It was happening anyway in India. So now raw diamonds directly coming from South Africa to Surat, and Surat became a Mumbai-Surat combination, became now a trading. Now diamond, look at this. Cutting and polishing happens in India. 70% of the world diamond cutting and polishing happens in India compared to any other country. Netherlands is nowhere in the picture, right? And this is more than $100 billion industry happened in just 25 to 30 years because of two young students taking initiative to bring lasers to Surat. I'll stop here. There are many, many such stories. You can read in this book. You can download this book. There is a PDF version, there's an iBook version or a Kindle version of this. There will be many more stories. One such stories, 3 more stories I'm going to develop. We are still working on it, collecting more information. The people who saved millions of children's life, these are the 3 major, scientists from India. Their innovation has helped across the globe, not just India, particularly from lower and middle-income countries. Then how we manage COVID itself, how Indian scientists participated in COVID. Madhvi Joshi is one of them, and how they, address this. Many, many academic places, research universities, research institutions, people contributed to addressing the COVID problem. And that's also a story worth to be told to the world. Stop here. Thank you very much.
Thank you, sir. That was indeed motivating and inspiring. As a token of our appreciation, I would like to request Reverend Dr. Father Chaman Thomina to present the memento to Professor Shashidhara, sir. Thank you, Father. Thank you, sir. Dr. Madhvi Joshi is Scientist D and a Joint Director at the GBRC Gandhinagar, which is a part of GSBTM. Before joining GSBTM, Dr. Joshi worked with Christ College Rajkot as a faculty in Department of Microbiology. She completed her master's and doctoral studies from Saurashtra University, Rajkot. Dr. Madhvi Joshi is a renowned biotechnology researcher specializing in genomics. Her notable contributions include sequencing work for studying antimicrobial resistance in India's poultry value chain. She is the head of various research projects of state, national, and international repute, and as Sir mentioned, she has played a key role during pandemic by bringing our state-level research to national and international platforms. Ma'am's achievements are a testament to her hard work, perseverance, and dedication to making a difference. She is an inspiration to her peers, colleagues, and the next generation researchers, especially aspiring women scientists. May I request ma'am to come up on the stage and honor young minds with her inspiring contributions and leadership.
So, very good morning to all of you and Reverend Father Jumon, Fernandez Madam, my mentor and long collaborator, Professor Shashi, my dear friend Neha, and many other people. As rightly mentioned, I started my career from this college and then moved out and went to the biotechnology mission to establish some of the biotechnology ecosystem, and now since 2017 I am into the research center. And very rightly, I think Dr. Shashidhara mentioned about how as a country and the different scientists contributed through their science in developing the country what we are today. So I'll be talking a little bit about future, right? Because that's expected being a young person. So I'll be telling about some of the emerging science what we are doing. And these are also the small stories that I have woven together to present it to you for a particular reason, because most of the time, as Professor Shashi rightly mentioned, we think that there is not much of a science in the country as a whole. And specifically when you talk about Gujarat, nobody can think that there are good scientists working here or good science being done. It's a very rich state, but it is a state cherished for a lot of other things, the business, the many influential people like Mahatma Gandhi, Sardar Vallabhbhai Patel, but not much of a science. So how we as Gujarat people, I mean you are the people who are pursuing science, and even when we talk about careers, how many of you want to become scientists? Can you raise your hand? The people sitting in the audience, how many of you want to become scientists? Yes, very good. So I could see still around 5% of the audience, they are thinking about scientific career. Otherwise, you would prefer to go to some university for teaching, then to industry. And I'm not saying that that's a bad choice of a career, but we need more science, we need more scientists for the country. In the global community, Indians are the top contributors in science. But we want those scientists to working for the country, as Professor Shashi mentioned, we have a lot of problems that are coming up in the near future, and pandemic was one such example. And also the opportunity that how, we overcome the pandemic with the help of science. Environmental surveillance. And this is, a journey how we started and what we are planning to do in the state, and how that became as a successful role model, not only for the country, but for also, a lot of international regimes. So I'll talk about that. And how many of you know what is environmental surveillance? Okay, so good. I have, a good definition to go ahead with. So basically, environmental surveillance is that in India, we all used to believe as Vasudhaiva Kutumbakam, right? I mean, the whole world is a big family. And then came the concept of human health, plant health, animal health. And then slowly, now everybody is talking about one health. So one health is, you can't make animals' life better without considering human health, vice versa, and also the environmental health. And beyond that, the planetary health. So the health of entire world is interconnected, interwoven, and that works in a very close balance. And if you disturb one of that balancing factor, it would have a catastrophic effect for the other counterparts as well. So you can't be in silos, you know. So nowadays, if you see the global science, global scientists, Indian scientists, they're all moving together for interdisciplinary science. The science that is, involving transdisciplinary people, multidisciplinary people, they all come together and work for solving some of the problems. So environmental surveillance is one such component where we understand the environment and try to predict the things for the betterment of human health and public health. So before moving forward, I think most of you would know, but just to give you a little glimpse about GBRC. So Gujarat Biotechnology Research Center is an autonomous center under Department of Science and Technology funded by Government of Gujarat, established in 2017. And we are a hardcore genomics, or you could say a omics driven center. But the mandate set for to the GBRC is to work on the societal problems. And the pandemic was, one, you could say, blessing in disguise for GBRC, because that also gave us a lot of opportunity to work, on the problems that were faced during the COVID-19 pandemic. So we do a lot of genomics. We have a very big biobank of close to 10,000 microbes. Many of them, they are AMR isolates, antimicrobial resistance isolates. Also the cancer biobank, and then we do a lot of bioprospecting and bioinformatics in that. So before moving forward, when we say about One Health, there are some small stories that I want to bring to you, and I'll just keep also my time. So when the COVID-19 pandemic came, it was, the catastrophe for the world, and nobody imagined that in the modern world we could also have a pandemic like this. Everybody knew about Spanish flu and then, some of the other small epidemics that are going on in the country, but nobody thought that it could impact the whole of the world. And when the pandemic came, GBRC started, one thing, and for that also there is a story. So one of my collaborators who worked in IIT Gandhinagar, we were working very closely for a lot of environmental work, but when the pandemic came, he came and talked to me that, Madhvi, why don't we start environmental surveillance or particularly wastewater surveillance for SARS-CoV-2. And at that time, I'm saying this is about early 2020s where, we were busy establishing RT-PCR labs in the state. We were busy doing the whole genome sequencing, and we were busy doing a lot of other things. We were going to the hospitals in ICU wards for understanding how, the host pathogen interaction takes place. We did a lot of human sampling during that time. So it was such a busy time, and it won't be an exaggeration if I say that we used to work close to 18 hours a day. And everybody in GBRC, whoever could remain present, they were working for the different solutions for pandemic. And then in the middle of that, he came and told me that why don't we start, wastewater surveillance. Says Manish Kumar, he is now, in UPS and in Mexico. And then he was so much of perceiving that we should do, surveillance in the wastewater. And he came 2-3 times, and one fine day I was so busy, and I said, okay, go ahead, collect some samples. If you are able to collect samples, then we'll do something about it. And I just wanted him to go away and never come back. But he came back with some samples, and then he told me that, oh, I brought samples. So I said, and remember that was the time, we were facing severe deficiencies for RT-PCR kit. I think Professor Shashi and many other people who were working in that area would know. And flights were coming with RT-PCR kits, but not landing in India and directly being diverted to the other part of the world. So those were the times, I am talking about. So for me, it was a decision whether to use those RT-PCR for human diagnosis or to use it for the wastewater surveillance. So I was little agitated, and then I told him that anyways you have collected this from trash, you can throw it back in the trash. But then somehow he never lose hope in what we could achieve together. And then he pursued me. He said, I don't have protocol, I don't know how to do it, but I know you can do it. So you start doing it. And then I said, okay, somebody is, putting a lot of pressure and never realizing what we could achieve out of it. We tried some samples and checked the presence of SARS-CoV-2 in the wastewater, and we could detect it. Now, what is big deal? If you are detecting a SARS-CoV-2 in the wastewater, what is a big deal? And then he said, let us do it weekly. I was further annoyed, and he said, no, let us continue it, for some period of time. I said, okay, I'm going to use only half reactions. For humans, we use the full 20 microliter reaction. For the wastewater, we'll use half reaction and see if something comes out. And then we continued it, for initially Gandhinagar. Then he brought also funding from UNICEF. And that is how, we started environmental surveillance in the SARS-CoV-2. But I keep, this part of the story as a poise and then move forward to the other part. So one of the biggest program which was funded by UK Research and Innovation under the Global Challenge Research Fund was One Health Poultry Hub, and we started working in GBRC for that. And the main mandate, because Gujarat is the state of vegetarian, I know, but when Professor Shashi talked about nutritional security, one of the important aspects is also the animals that are used as a part of the food security, like poultry. So they are grown in a very intensified way, because in 35 days from an egg, the chicken has to reach to market and achieve the weight of around 1 to 1.5 kg. So during that time, they feed them with a lot of antibiotics because they don't want them to get sick. They want to send them to the shop and then further to the market value chains. So a lot of antibiotic is fed to poultry, and that also leads to generation of AMR. I was again not much concerned. I said, I am a vegetarian. What if they are using antibiotics in poultry? How it is going to affect me? But the results, that we identified in those poultry value chains is because the litter, that is a waste of the poultry farm, is being a rich source of nitrogen. It is also used in the agricultural fields for growing plants. So now you are concerned, right? Because that waste is coming to the agricultural value chain. And we could also establish with a team of BHU scientists that AMR is transmitting from the poultry waste to the soil, to the root, and also to the plant. So that is, one of the other story what we are working on it. And then, third thing is the environmental surveillance beyond human. So we are concerned about human only. But when we say everything is interconnected, we cannot leave animals aside. And everybody knows that COVID-19 was thought to be, a disease that originated from, some of the other animals. So there are also 2-3 theories, how it originated. And then finally, it is a zoonotic disease that transmitted to humans and created a catastrophe. Similarly, I think those who are having, some of the cows and buffaloes at your house, if you are into farming practices, you must know about the lumpy skin disease virus. Just after the COVID-19 pandemic, I think more than 10 lakh cattle and cattle, they died, at least in Gujarat itself. And that was caused by the lumpy skin disease virus. Another important virus for the animals is the foot and mouth disease virus. And third thing is avian influenza. It is again in the news right now, if you are looking at the scientific developments. So this H5N1, with a single nucleotide change, now it has changed its host and it is able to infect to cows and to pigs, and also there are some cases of the transmission to humans, and those cases they again trace back to India. So the people who have traveled from India to abroad, they are diagnosed with this sort of illnesses. So diseases and viruses, they don't see boundary. And when they don't see boundary, you have to work in a broader holistic way. So the last project that is put forward there, where Professor Shashidhara is leading from the country, and this is funded by the Bill and Melinda Gates Foundation, where in country at different states, that is in Karnataka, Gujarat and Pune, we are trying to establish the environmental surveillance for these diseases. So that is it. And then everybody in Gujarat has heard about Chandipura viruses, right? Which was the death of a lot of young children were taking place because of this unknown viral encephalitis, and the samples were being sent to NIV Pune. But then the diagnosis takes a lot of time. We get samples sent from here to Pune. The results, they used to come back maybe in a week's time. So then with the support of NIV Pune, GBRC started diagnosis of Chandipura virus, and less than 24 hours we were providing diagnostic to the hospitals for the Chandipura detection. And so many other things, CDV work in Asiatic Lion, the network program on AMR. But without wasting much of a time, I'll directly come back to the story. So when the pandemic came, and this story would relate to each and every one of you sitting in this auditorium, because when you really want to pursue science, you don't need fancy things. With whatever things are available at your hand, if you continue working towards it, someday you will achieve a lot of good things. So when the pandemic came, and being a Genomics Institute, we received a phone call from Honorable Chief Minister's office that what GBRC can do in this pandemic. So, I was obviously enjoying the lockdown, because otherwise also we are very busy. And then we got a call that what GBRC can do. So we prepared, a couple of slides and a presentation. In the entire state that were doing the SARS-CoV-2 diagnosis. They were part of the ICMR VRDL network. And we went ahead and we told that we can also start with that. Moreover, we are a genomics institute, so we can do the genome sequencing of the SARS-CoV-2. And I'm talking about exactly, the first positive case, which was from again Rajkot, a person who had traveled to Saudi and came back and found positive. And at that time, Rajkot didn't had VRDL. So the samples were being tested by Jamnagar Medical College. So they asked us to, go and collect the samples. So nobody was ready. Even, the scientists working with us, they were in fear that they don't know about this virus and it is airborne. Nobody wants to go. So I said, no worries, I will go. So I took my office car, and that was, the most enjoyable ride, because nobody was there on the road. I traveled from Gandhinagar to Jamnagar, collected the positive sample, and that was exactly around 4th or 5th of the April 2020. Went back to GBRC, again challenges, because, those who know a little bit about genomics, a virus in an active stage of infection used to give a CT value about 25, 26. And if you estimate, the genomic copies of virus in a human blood will be very, very less to be detected by the whole genome sequencing methods without a proper amplification method. So what we did is, we did a total transcriptome of that person, because SARS-CoV-2 is a RNA virus. We collected by that time around 4 to 5 samples, and hopefully in one sample we could get the whole genome coverage through our sequencing, and that was exactly 17th April 2020. when the first SARS-CoV-2 genome sequence from Gujarat and second from the country was released. And that is how, and that is how everybody realized that, oh, there is something called as GBRC. I think before that nobody even knew about what GBRC, you knew it, but I'm talking about a general broad, scientific fraternity. And since then, our chief minister also tweeted, and then DBT, Department of Biotechnology, said that they would do 1,000 SARS-CoV-2 genomes through INSACOG network. Our chief minister also declared that we will do 100, but we didn't stop that 100. When I'm standing here, we did more than 14,000 SARS-CoV-2 genome sequence from the country. They also became a part of, the INSACOG team. But that's not a story of, the leadership that I want to talk to you about today. We also looked at SARS-CoV-2 from the non-human host. So we tested a lot of domestic animals, for the presence of SARS-CoV-2. Also did genome sequence to understand that how it could, come back to human. This host pathogen interaction is the only study till date which is done on around 600 individuals, 200 who remained asymptomatic, 200 that remained symptomatic, 200 who died. And that work is also published in Nature. So that's, the part of the SARS-CoV-2. Chandipura, I will just keep, this is, the genome that we could extract it from this last outbreak. And we also developed a sequencing method for Chandipura virus. But I would again now come back to what happened to those samples, that my collaborator collected and, gave us. So now getting into the real environmental surveillance. Can you see this picture? I have used AI. Now, Professor Shashi was talking about a lot of technologies, and one of the upcoming technologies are artificial intelligence and machine learning. So, what happens when you survey the environment or the wastewater? I'll just give you a simple analogy. When you fell ill, you will go to doctors, they will prescribe you with some medicines. If you're still not recovering, they would suggest you blood test first, right? Why blood test? Why not any other test? Why blood test? Because blood is a homogeneous representation of an individual's health. They will look at the entire CBC, CRP and all those stuff. Similarly, if you are considering our sewage network or the wastewater network, that reflects about the community health. It is a homogeneous sample to what is happening to our community. And that is how it is linked with each other. So specifically, taking about SARS-CoV-2, when you look at this pyramid, do I have a pointer? So when you're looking about this pyramid, you would see that in any infection, the bottom pyramid is all the people who are infected. Okay. Then the second one is, the people who are infected, but they may not be showing any symptoms, like they remained asymptomatic. I'm talking about this. So the people who remained infected, they are shading it, but you are not able to detect it, Then these are the people whom you are able to capture with the RT-PCR or the rapid diagnostic method. These are the people who end up into hospitalizations, ICU, and those who cannot recover from a particular symptom. So this is, the missing piece of the puzzle that is provided by the environmental surveillance. So now coming back to the story, if you will read the timeline here, the year is not mentioned, but this is somewhere early September 2020. And this is where, we started the environmental surveillance. We started looking at the copies of the SARS-CoV-2 in the wastewater from Ahmedabad and Gandhinagar. So what? So then we compared it with the active cases in those cities. And we could very clearly see a 2 weeks of lead time here, which means an individual, and then later on it was also discovered that the ACE2 receptors, which are the main receptors for the SARS-CoV-2, they are also abundantly present in your intestine, and because of that, individuals start shedding the virus in the stool, which comes to your sewage network, and through the sewage network, you are able to identify these things very, very early. So 2 weeks of lead time, can you imagine during Delta wave, when we know what will be the situation after 15 days, what does it do? It gives you a lot of time for the public health actions. You could prepare your hospitals, you could also prepare your diagnostic facilities, you could also inventorize on what all your requirements will be. So this is what an environmental surveillance can give you as a advantage or a benefit. So it gives you a lot of time for public health action basically. So what? So we started doing it, and then we showed these results to the higher authorities in Gujarat, the health department, the chief minister's office, and there was a special task force on the COVID-19, so they were also monitoring into this, and we continued surveying this. And this work was one of the first reports from the country where you could actually provide a 14 days of lead time for the SARS-CoV-2 pandemic, and that work also got published into Stoten, and that is one of the highly cited papers of GBRC so far. And after that, pandemic was going on for 2-3 years, and we were also continuing this surveillance. So what you see here is a graph. The blue color is, the copies of SARS-CoV-2 that you detect from the wastewater, and the orange were the active cases. Now, once WHO declared the end of pandemic, no state or the country was forced or, required to carry out the regular testing. And what happens, at this point of time, we didn't get any further clinical case data. So here you could see that we had a very clear lead time of 14 days. We were able to tell government what to take actions. To that an extent, whenever the next wave came, every time before imposing any of the restrictions like mask or social distance, government would ask what is the case in wastewater. And if they see that wastewater trend doesn't say much of incidence, then they would not impose those things. And these are the stories that would never reach to even scientists or the common people. So that's why I am also taking a liberty to share. But you can also see scientifically that when you do not have clinical data, now your model is established for the SARS-CoV-2, and in absence of this data, you could also see that there were so many silent waves that were going on. So the SARS-CoV-2 is still here. We are still continuing to monitor it, but the only thing, because of the efforts of the vaccine development and all, we are all now not getting into clinics. It is remaining asymptomatic, but there are still many variants going on. So what does it do? So the wastewater surveillance now has a proven evidence, and it can be dependent even in absence of clinical data. Because majority of the people say, that you are doing it from the wastewater, how can you extrapolate it to the whole of a community? And as Professor Shashi said, the science needs evidence. So this is the evidence, that even in absence of this, you can trust the wastewater data. Another important thing, being a genomics institute, we also started sequencing SARS-CoV-2 from the wastewater. And this particular picture should draw all of us attention by two things. This is a sample collected from the Winzol STP, which was collected on the 8th February 2021. The entire world was unaware about the Delta and Delta wave. Okay. And we did a whole genome sequencing, and that's a metagenome, because even within the COVID, there are a lot of variants. But which variant would have advantage in the public, or which variant would have a highest clinical implication, that can be identified and picked up using the next generation sequencing. So you would see, this particular line in the table, that is a reference position of the SARS-CoV-2 genome, which is around 30,000 bases only. And this is a 6 nucleotide deletion in a spike protein. And this 57% frequency, so this says that even in the 8th February sample which was collected from the wastewater in Ahmedabad, the delta was present at 57% frequency in the population. Now all of you know that the delta wave started in Gujarat specifically from the March first week onwards and created a havoc. We have seen those were one of the worst times for humanities, and then it came down after the June or so. So what does it tell you? When you use technologies like this, you can also tell a lot of it about the emerging variants, the new variants that are coming up, the new variants that are, going to impact the population. So that is what is the power. So we as a scientist, we are always curious, and we are not satisfied with what we did in SARS-CoV-2, because COVID was maybe, once in a 50 years, once in a 20 years story, but we are always going through a lot of epidemics of dengue or maybe, other seasonal flu-like infections and all. So we thought of extending, the fruits that we got from SARS-CoV-2 to beyond SARS-CoV-2. And then we started surveying 25 locations from the state of Gujarat every 2 times in a month. Same, the sewage samples, and we established a complete baseline data of what all viruses can be detected and how can we correlate it with the different type of clinical cases. So we checked, so this is, one panel which is available from the Twist Biosciences, and this panel has an ability to capture close to 3,153 viruses, including, and these are mostly pathogenic viruses, pathogens for human, pathogens for plant, pathogens for animal, birds, etc. And it could also capture single-stranded, double-stranded DNA and RNA viruses. Along with that, we also have a control panel to keep the benchmark. But the most important part is that, we have collected so far around 964 samples from different parts of Gujarat across the season. And we could detect, close to 164 DNA viruses and 124 RNA viruses consistently from this wastewater. And as you can see, that at strain level it is even higher, close to 300 DNA viruses and 441 RNA viruses. What you see here is, maybe a colorful graph which looks so good. But this talks about the diversity of the viruses that were detected in each of the wastewater sample from the different parts, and this is over a period of time as well. Okay, so you also get that picture. What does it tell you? Now, if you compare the seasonal variations, you could very clearly see that some of the viruses, this is monsoon, this is winter, and this is summer, so how their population is declining. You would also see, some of the viruses which are increasing. For example, these orthomyxoviridae, it's a pox type of viruses. And then there are other viruses. So you could also study the seasonal variation on the viral population. Beyond that, these are the trends of these viruses from the wastewater samples. So this one is a SARS-CoV-2. We were also able to capture the different waves of SARS-CoV-2 using our different method, that is a whole genome sequencing method. Other than that, rotaviruses, influenza A, hepatitis A, human para-influenza viruses, noroviruses, enteroviruses. So all these viruses we were able to detect and also analyze the trend. Now, currently also, while we are talking, the team is trying to work on looking at the AI/ML models of how to correlate these viruses with different outbreaks, And again, being a scientist, there are always questions that if you are doing just a detection, just a trend analysis, so what? I mean, how do you correlate? For SARS-CoV-2, we were getting RT-PCR confirmed cases for our graph to compare with. Do you get it for influenza? No. Do you get it for any other fever? No. Even if you have fever, you never bother to know which type of virus you were infected with. So far, so you are okay, you recovered, and everybody forgets. Neither the doctor is interested, neither you are interested in knowing what virus it was. So we tried to establish a model, and you could see this model on this side is the detection of RT-PCR based SARS-CoV-2, which is now the approved thing. And you could see we were able to see the peaks captured. And the same thing we were able to also capture in an independent method. So this is also a cross validation that how this type of the methods we can deploy it for the betterment of public health. So today when I'm standing here in front of you, at least in Gujarat, we have ample amount of data for the baseline of what we can do and what we cannot do with the wastewater surveillance. So it is dependable, it is deployable. Means after GBRC, this also can go to a public health laboratory. They can also test it, and it is easily doable because it doesn't involve a lot of science. And what is the impact that it created? So this is the WHO guideline on environmental surveillance for SARS-CoV-2 to complement the public health action. And the GBRC work, which we are talking about today, is also referenced in this WHO guideline. And I'm also part of, the European Union's Globacon, which is a global network on the environmental surveillance, where I am co-leading the R&D concept paper, where we would be defining the strategies for the global scientists on what are the challenges that they can address with the wastewater. So that is it, what I wanted to share with you today. It is a story that a science with a good perseverance and some common sense, everyone can do it. If I can do it, you can also do it, and you can also make your country proud. Thank you so much for listening very carefully and patiently. Dhanyawad.
Thank you, ma'am. Your stories have indeed motivated us all. The roots of all goodness lie in the soil of appreciation. Oh. The roots of all goodness lie in the soil of appreciation. May I now request Dr. Neha Jangbari to propose the vote of thanks.
Good morning all. Science is a way of thinking much more than a body of knowledge, rightly said by Carl Sagan. As the convener of the 15th National Science Symposium, it's an honor and privilege to deliver the vote of thanks for the event that has truly enriched our understanding of science and its role in society. First and foremost, I express our deepest gratitude to Dr. Shashidhara, a Bhatnagar awardee and distinguished professor at IISER Pune, for accepting our invitation and delivering a brilliant keynote address on science education and research in independent India. Your profound insights into the evolution of science education and its transformative impact on the nation have inspired us all to think critically and aim for excellence in our pursuits. Thank you, sir. I would like to express sincere thanks to Dr. Madhvi Joshi, Scientist D and Joint Director at GBRC Gandhinagar, for delivering an engaging expert talk on environmental surveillance as a potential tool to complement public health. Your session provided invaluable perspectives on the intersection of science and public health, opening new avenues for research and innovation. Thank you, Madam. I would like to convey sincere thanks to Reverend Father Dr. Jomon Thamanna, Director of Christ Campus, for his visionary leadership and continuous support. Your guidance has been pivotal in organizing the symposium and fostering a culture of academic excellence at Christ College. Thank you for mentoring us in all our activities and ensuring that we always do the right thing in the right way. Same time, giving us an opportunity to work with freedom. Thank you, Father. I take this opportunity to thank Reverend Father Stanley Joseph in his absentia, who is Finance Administrator of Christ Campus, for his continuous support, which ensured the seamless execution of this event. Our heartfelt appreciation goes to Symposium Chair, Dr. Yvonne Fernandez, Principal Christ College, for her inspiring leadership and dedication to nurturing a vibrant academic community. Your enthusiasm and commitment to innovation have been central to the success of the symposium. We always thank you for your continuous support available 24/7. Thank you, Madam. A special thanks to Dr. Narottam Sahu, Advisor and Member Secretary Guj Coast, and Dr. Poonam Bhargava, Principal Scientific Officer Guj Coast, for their generous sponsorship and unwavering support to initiate that promote scientific exploration. I thank Professor C.G. Joshi, Director, GBRC Gandhinagar, for his continuous support for making this event a grand success. I thank all the invited judges and the faculty members who have come from far and wide to support and encourage the students. I even thank all the participants for remaining present in this inaugural ceremony. Finally, I extend my gratitude to the organizing committee, faculty members, staff, and student volunteers who worked tirelessly to make this event a grand success. As I conclude, let us use the inspiration and knowledge we have gained today to contribute meaningfully to science and society. Thank you all once again and have a wonderful day ahead. Thank you.
Thank you, Madam. Before we conclude, I would like to invite Jagrut Sir to make a few important announcements.
Good morning, one and all present here. Now we are about to start with our all the tracks. Just listen to few important things. The B group tracks will be held at this floor only. Oral and poster presentation. The venues and schedule is already there in your kit. One most important thing, throughout the event you are supposed to wear your ID cards, which is already there in your kit. Keep that food coupons with you throughout till the valedictory at our Science City. A group presentations and oral presentation, poster presentation will be held at the ground floor. As per the guidance of your event in charges, you may please proceed for the lunch accordingly. We need to maintain the timings for the lunch and everything so that we can depart for Science City at our given time, that is 2:30, we are departing from here and will be there around 3 o'clock. 3 to 5, we will be having the visit, which is organized by them only. And 5:30 sharp, we will be starting with our valedictory and award functions. We will be winding up around 6:30. And then after high tea, we will be coming back again here only. And from here you can depart at your places. We will be providing the bus facility to you from here. So all of you are requested to remain present immediately after lunch at the ground floor classrooms. From there only you will be guided in which bus you are to go. That's it. And for any kind of help, our volunteers, our faculty members and help desk is already there. So you can move towards your venues. Thank you very much.